Welcome to this month's DPRG membership meeting. This month we've got the Iron Rain team who's going to come and talk about their robot. Recently won some awards at the Super Regionals, is that right?
South Super Regional.
South Super Regionals, and it's heading to state championships next, right?
Right.
So I'm going to give it over to Kareem and team. Iron Rain.
I'm Kareem. It's Jayesh. It's Tycho. All right, so we're going to start out by, how many of you know anything about this year's FTC game? Did anybody do judging? You did judging, right?
I did judging.
You did judging?
Yeah.
All right. So in order to set the context, because it just won't make sense unless you understand what the challenge looks like, we're going to go ahead and run a quick video that describes what the challenge is, how it works.
The robot must be built from materials specified in the game manual and fit within an 18-inch sizing cube. After the match starts, the robot may expand. Each match is played with 4 randomly selected teams, 2 per alliance. Your alliance partner for one match may be your opponent in another. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. At opposite corners of the field are 2 corner vortices, red and blue. Between them is the center vortex, which can freely rotate. 4 beacons are mounted on top of the field walls. Below each beacon is a unique vision pattern for navigation. A white tape stripe leads up to each beacon. The field is divided by red and blue tape stripes. The velocity vortex game includes particles that are 3.75 inches in diameter. There are also 2 cat balls 21 inch in diameter. The cat balls are placed in the center vortex assembly. Teams place their robots on the field, touching the wall in front of their alliance stations. They may preload 1 or 2 particles, up to 3 per alliance. Before the match, field personnel randomize the 4 beacons. The match begins with a 30-second autonomous period. Robots can only operate by pre-programmed instructions. If a robot presses a beacon button matching its alliance color, the alliance is awarded 30 points. Also, an additional particle will be added to the field before the driver control period begins. A cat ball in contact with the floor will earn an alliance 5 points. Each particle scored through the center vortex earns 15 points, and particles scored into corner vortices earn 5 points each. At the end of the autonomous period, if a robot is parked partially on the center vortex base or corner vortex ramp, that alliance is awarded 5 points each. If a robot can park fully on the center vortex base or corner vortex ramp, the alliance is awarded 10 points each. After the autonomous period ends, the field personnel introduce additional earned particles into the field. Then, the 2-minute driver control period begins. Now, each particle scored through the center vortex earns 5 points. Particles scored into corner vortexes earn 1 point each. During the driver control period, alliances may capture or recapture a beacon. Whichever color is lit up at the end of that match earns that alliance 10 points. The last 30 seconds of the driver control period is the end game. During this time, robots may lift the cat balls to earn extra points. If your robot is holding a cat ball off the playing field floor at the end of the match, your alliance is awarded 10 points. But if your robot can lift it above the center vortex crossbar, your alliance earns 20 points. And if a center vortex is capped, that alliance gets 40 points. The game manual also lists various penalties to help ensure fair gameplay. For example, robots may not descore a capped ball. A robot may not extend above 29 inches before the end game. A robot may not damage the playing field. A robot may not pin another robot. This has been a brief summary of the Velocity Vortex game and does not include the latest updates.
Pretty good competition.
It's pretty complicated.
Formed with complete rules.
And you have to choose your strategies that you're going to implement because you can't do it all. Although a lot of teams try to do it all. We kind of tried to do just about everything and didn't quite get there.
How many points does most teams get? I mean, there's a lot of 5s and 1s. And
There are a lot of,
ones that usually
yeah,
add
so
up to-
they can add up. If you take penalties out, so penalties get awarded to the opposing alliance, so you get called on a penalty. And some of those penalties are up to 40 points. Those are the major penalties, or there might be 10 points. But the typical game was probably around 150, something like that, but there were some that got all the way up to 300. The winning robot at the South Super Regionals, the one that won the game portion, not the awards portion, is one that we went up against, and they totally destroyed us. And they were scoring 300 on a, not on a regular basis, but quite a few times. And what they did is they specialized in just scoring what they call the particles, these right here, right? It's just a wiffle ball, softball size. And they just specialized in popping those up and going just real fast. They didn't have the ability to lift one of the cat balls for the 40 points at the end. They had a pretty good autonomous though. What separates a lot of the teams out is you got to have at least one team that has a strong autonomous in your alliance at like the super regional levels, or it's not going to go anywhere. So that's the part that you're probably more interested in. Knowing the history of the group is the autonomous. So we're going to go ahead and run a quick robot reveal video. You got that queued up? Most of the advanced teams put together a video that describes the robot, and it's just like a 3-minute video. So we're gonna run ours. This cost us a little bit because we made some mistakes that killed our lift during filming of the video. And that meant we weren't able to demo it to the judges, and that made a big impact on the fact that we did not move on to advance to worlds. We were one slot away from advancing to worlds. So
One slot?
we are the first alternate. If any other team backs out of going to worlds, we get it, but that's not going to happen because it's not going to happen. We're like 2 weeks away from that, so.
Okay. So are you guys still pushing on the idea that it could happen?
That's what it's been a long season. They've been doing this since basically this time last year, right? At the end of our regional championship last year, we didn't make it to supers, and that basically defines the beginning of the whole next season. And so they've been working on it for a long time, and it's just it's kind of exhausting. And when we know that the chance is so slim that we're not expecting to go, but we're still working on that. So the state championship is a separate thing that's run by UIL, and so we'll be going to that in late May. So that's what we're preparing for right now. That's my redneck backyard. And that's where you don't have an indoor space to practice on. So every time it rains, we get the field flooded, and that's what we got to work with. This is the first time we've actually had a practice field. So that's showing off the Mecanum drive. That's our particle system. This is our third major iteration of the shooting system. We're picking up the particles off the floor with rubber band track, basically. And that's the gate that controls whether it goes into shooting. You can sort of tell the rubber bands are going real fast right there. Now it's going to eject them. So one of the major penalties is if you capture a particle from the opposing alliance, every 5 seconds you have that in a robot, you get a pay penalty. So you got to be able to eject it. So these are the beacons right here. It's kind of hard to tell in the daylight what the colors of them are.
It looked like you were just running into it. Is there a way that you're selecting the left or the right side?
Yeah, we'll get to that. I think you'll see it a little bit here. So this is our original autonomous mode, and there's a color sensor on the side of the robot. You want to explain it, what you're doing here? You want to explain it? You're not going to do it? Really? All right. So as we're scanning past it, it's going to give us back a value, whether it thinks it sees the red or the blue, and it's mounted just at the optimal spot. But you only have about this much error in terms of how close you need to be to it. If you're this far away from, 8 inches away from it, it's not going to see it. So they're using odometry and an IMU to really control their approach, so it's close enough. What's this here? This is
That's just mechanical.
Macadam Flex Freedom. So this is that's a NinjaFlex wheel that they printed. That one is the older one that's 20% infill, and they've got a newer one that's that one right there. And the newer one is 35% infill.
Just driving around.
Just driving around? All right. Yeah.
So that did not show you getting the lift. Was that just because you didn't decide to put that in the video?
They
or-
broke the,
We got
they
it.
broke the lift while they were filming the video.
Oh, gotcha,
It
okay.
wasn't the people who understood how it was rigged and,
Yeah.
checking on it, and
Okay.
so it was,
So are we going to see the lift
it's,
today?
it's a weak excuse. No, you're not. Well, we can show you sort of how it should work a little bit, but we're going to be actually manually moving it. It's still not properly rigged.
Gotcha.
It just got put back on the robot yesterday,
Mhm.
And so it's not fully rigged.
Break it again.
Huh?
Break it again.
Break it again. Well, we got to get the wiring rigged, and that's probably a 2-hour job.
And
just
that's the
to-
part that
just to get
breaks.
Huh?
That's the part
That's
that
the
breaks.
part that
anyways.
breaks, yeah.
How many on your team?
Huh?
How many on your team?
11.
11. Yeah.
Because I have to ask
This
this
was like the
question.
last minute, last night, I just said, maybe we could just bring the robot and, do a show and tell. And so I didn't have enough time to gather everybody around for
Kareem?
a full presentation.
Excuse me. I have to ask this question.
Sure.
What is your ginger mix?
We've got 2 girls.
2 girls, okay.
Wait, 3? 3.
3.
Three.
Charlotte, Charlotte, yeah, Charlotte's new.
Okay.
Charlotte's new, but we're gonna lose one as a senior. We're losing 5 seniors this year,
Okay.
but they've been with us since
6th grade?
since 6th grade.
6th grade, wow.
Congrats.
Yeah, we've been together for a long time.
Yeah.
So,
Not
but
leaving yet.
huh?
I'm not leaving yet.
No, he's here for another year. He's our master programmer.
Okay, cool.
And so he does all of the Java coding. So the robot itself, the control system is an Android. And you've got 2 Android phones that are talking to each other. One is the driver station, and it's connected to a joystick, and it's sending signals back and forth during driver controlled mode. But during teleop, during autonomous, it's just sending telemetry back so that you can see what's going on and do some debugging and such. So are we gonna, and so the Android phone on the robot itself, you're basically writing an Android app that has some, a framework attached to it for robotics that was developed by the company that sells all of the modules, and there are specific modules that you have to buy. It's called Modern Robotics. So there's not a whole lot of flexibility, but there is a sensor input-output module that you can connect I2C devices to analog devices, that kind of stuff. So you can, the rules basically say that if you can use any kind of off-the-shelf sensor that is powered by
Phone.
huh?
The phone.
It's basically powered by the phone. Yeah.
So
It
does the
needs-
phone talk on like Bluetooth, or how does the phone talk? What is it?
It's all USB.
Huh?
It's USB. The two
You
phones
know,
talk
the
to
two
each,
phones
the
use Wi-Fi
phones talk to
direct.
each other over Wi-Fi direct, but
Right.
the phone on the robot talks to the control system all through USB.
Oh, okay, that's nice.
And that's, it's nice, but one of the things you'll notice is that a lot of the robots have to have a way to onboard those particles real fast. And it tends to be rubber against plastic or something like that. They're basically static generators, right? And USB is not really friendly with static. So one of the things that's missing from our robot right now are the side shields. We put Lexan side shields all the way around it, and that's absolutely necessary in order to slow the dissipation of static shocks. Because when we didn't have them on the robot, we just drive for a little bit and touch the side walls or another robot, and zap, and we're dead. And it would take,
Did it kill them
20,
too?
30 seconds, huh?
Did it kill both robots or just you?
No, just ours.
Generally ours.
Not a good strategy.
There was one case where all 4 robots died at the same time, but then again,
Yeah.
3 of them collided with each other at the same time we hit the wall, so it probably wasn't us. It was the fact
That
that
one
they
wasn't
all hit
us.
each other.
Yeah.
Or we EMP the field, but either way.
Yeah.
Maybe a little mist generator or something, to make the.
No, they actually started spraying the fields with anti-static spray, but that also, creates problems for robots that have a certain odometry profile, and then the field gets a little slick. So there's always trade-offs. Okay, so are there specific things that we want to demo first?
Yeah, yeah, go ahead.
You want to throw it down and,
Um,
all right, so let's,
your vision?
huh? Let's talk through the sensors.
Okay.
Should we do that?
Are we gonna do the promo video?
You guys want to see the, yeah, they may not want to see this. It's, so part of this is awards driven, and that has a lot to do with your outreach and how you share your message with the community. And so this team has always been really big on that. So like the thing that we did go to last week at the iMake at Fort Worth, we've been there the previous 2 years. We do probably 10, 15 events like that per year. So we're really, really active in sharing the STEM message. One of the things we don't do very well is to get the highest awards. They're focused more around promoting FTC specifically, or first, this particular robotics program. So if you do something like host a qualifier event, you get recognition for that. You get less recognition for doing just general STEM outreach. And because we've focused more in a general sense on the community, we might have been better off in the awards and actually gone to Worlds if we hosted a local qualifier or something like that.
So this specific video is about like we do those STEM exposits that Mr. Barney just talked about, but this year we found Mr. Barney got an old 90s RV, and we basically renovated it for the sole purpose of driving around neighborhoods and teaching kids about robotics and STEM stuff they wouldn't normally learn about. So we basically roll out, and we have like we have EV3 robotics on board, and then we also we roll it out, and then inside we teach kids about 3D printing and Google SketchUp, and we have 4 3D printers on board that they can put little keychains on. So that's what this video is mostly about.
I think quite a few of them have actually been on the vehicle. I brought it up here once, but I'll just show this real quick.
Hello, FTC. We've learned from dedicated volunteers from other teams, and we've taught, kickstarted, and adopted more teams. We've evangelized the first at over 50 STEM events and helped thousands of families learn how to get started in robotics. But robotics is expensive and is not equally available. Dallas has the highest childhood poverty rate of the country's 10 biggest cities. Lacking summer care and transportation, these kids can get locked into summer learning loss. So when Dallas City of Learning needed help creating a mobile STEM initiative, we jumped in. We got a 20-year-old RV, ripped out the residential interior, and transformed it into a STEM classroom on wheels. Best Buy, Big Pond, and the Maker Foundation provided the tech to put on board, and we installed it and got it running. Last summer, we taught robot sumo and 3D printing in 18 underserved neighborhoods and proved the idea. Now Big Pond is raising the funding to offer year-round for free. And this is just one example of teams around the world paying first forward.
So we got an award for that video as a public service announcement, basically. But they were unable to play it at the championship because they had transcoding issues. Okay. think we do, is there anything that we need to go over in actual presentation?
You might want to use the slides about the IMU and the vision and stuff. They're at the bottom, or near the bottom.
Yeah, you knew this better than I do that.
Okay, so basically the presentation is one of the main components we give to the judges. It's how we tell them what we've done over the entire season, and we talk about outreach, we talk about the mechanical stuff and everything like that. But one thing they really care about is the engineering process, and we kind of did like a little bit of an extra thing this year, which we had one of our team members wrap this, which is interesting. But basically we talked about the engineering process and how we went from model to model based on how good they were and how each model actually affected everything on the robot simultaneously, and that this like process for one system on the robot would affect the next one. So, for example, that's one of our earlier flywheel models, and we wanted to we were testing out different percent ninja flexing builds to see how much grip they could do and to like have accuracy when shooting the ball. So that is 50%. This is 25 or is it 35?
That's 20%, that's 35.
Yeah. So basically, if you want to come up and like just like squeeze the side, you can see like the difference in each, and then you can see like the different grips that we tested out. Other processes we had are these button pushes on the side. We actually the very first thing we had were like school erasers, which worked pretty well, but they were like ripped apart easily. And funny story, we actually had to order those and we wanted free shipping, so Mr. Brownie ordered it with beef jerky.
In order to get it above the $35 threshold so we could get it right away.
Yeah, but then we found that those ripped off pretty easily, so these are foam, and we made these for each side, we just like secured them with rubber bands.
Those are actually silicone.
Oh, silicone, yeah.
Those are two-part silicone, so there was still 3D printing involved, and you can still see the pattern on there.
We
Max
3D
had
printed
to
a mold out of
create
nylon.
a mold out of nylon, and that was 3D printed, and then the silicone two-part mix was poured into that, and that's.
Is there any beef jerky in?
There's no beef jerky in. Oh, maybe I should have tried that. Yeah, really wanted the composite material, in, right?
Shoot a particle, shoot a piece of beef
Except
jerky.
first, no animal parts, that's disappointing.
Right, and another one of the parts that, actually this is probably the thing that's remained the most constant this year, is we decided for the particle collection, some people use like beater bars, but we found those to like, before when we used those, they like jammed up, or we had issues with like intaking them perfectly. So in this year, we took rubber bands, and they just gave us pretty smooth intake. And these, like Mr. Ryan said, they kind of like generate a lot of static, but we've been able to counter that with anti-static methods. But this gives us a lot of like smooth intake compared to a lot of teams, because over the course of time, there are teams that will intake it a lot faster, but this is like 100% secured. When we get a ball in here, it'll always go in.
You want to run it again real quick?
Yeah.
And you can sort of see underneath what's going on. You didn't. Let me do that again. Let it go a little bit longer. All right. So there's a funnel in here. This is all printed 3D plastic and nylon, and then it pops it into this curved chamber that brings the ball up. They called it the worm because it kind of looks like a grub right there, but that's actually like 5 or 6 3D printed parts that are bolted together to create that composite. And basically the conveyor just pushes all the way up, and then there's a gate right there, and the gate is operated by a servo, and then that's what releases the balls into the shooter when it's ready to shoot.
You say you 3D printed nylon. What do you know what the nylon you're using? What type it is? Because
It's bridge.
it's the bridge. So that's
Almond
actually
bridge.
the softer stuff. Okay.
Yeah.
Okay.
Yeah.
All right. Cool.
We've got some of the 910 as well.
Yeah. That's the one I've played with.
Yeah, it depends on what you're doing, but I think we sort of learned to design for the flexibility of the bridge and sort of stuck with it, because that was the first one we tried out because it was supposed to be easier.
Was it?
Huh?
Was it? Was it easier?
Well, it was easy. It was actually pretty easy. On our printer, we got a TAS 5, and the only reason that you got to put the glue down there is to well, you just cover it with your regular glue stick or whatever,
Yeah.
and it printed almost as easy as as ABS.
That's
It took a
cool.
little bit of getting used to in terms of how it bridged and the tuning in the temperature for that particular printer.
Do you use a fan on your nylon?
No,
Or-
we turned the fan off.
Okay, that's what I was wondering. Okay.
So yeah,
We shoot.
just a little bit more about these right here. The reason we went with silicone was to get sort of similar texture to a human fingerprint or human finger, because these are the buttons. We've got a bad connection here.
We do.
Oh, great.
Okay. This is not a good
We
battery.
got a dead battery. All right, so these buttons right here have a ridge around them. They were designed for a human to press, not for a big sheet, robot or whatever. So this, when you come up later, if you want to sort of feel how it presses, it basically conforms around that and still manages to press the button.
And a super important part of the robot, like every year, is our drive chassis. So before we've experimented with like Omni wheels, with like regular wheel in the middle. But this year we switched to Mecanum wheels, which gives us a lot of freedom with like movement. So instead of a robot that would have to completely turn around to turn a certain way, we just like strafe side to side, and that gives us a lot of freedom. Although it does help with the static as well. So regular Van de Graaff generator you have here. But yeah. That's one of our earlier shooters. So before we had the flywheel, we had this like catapult type system, which is really accurate, but the problem with it was that it was really slow. So instead we went to a bit of a quantity over quality test, which this like scored about 70 to 80% of the time, and it missed once in a while, but it was shooting a lot faster, and that's why we switched over. Did you want to shoot?
Sure. It's going to shoot in that direction, so you might. Yeah.
Okay. It's gonna go, choomp, it's gonna go up,
Shoot
right?
it at you, yes.
Yeah, okay.
It's gonna go this way now.
You can see there's an awful lot of backspin on it, and the material that the robots are actually going on is a foam
Right there.
type of material. It's this down here. It's a very dense foam, and when it hits on there, what it tends to do is pull the ball right back to the robot, which is what we need to do. It's like it's our cycle rate. Yeah.
Yeah, this is just a slide we had about the different materials we've experimented with, and how we've gone from all these types to see which are best for the different situations. So right now we're using Engine Flex nylon on this robot, but before we tried ABS like last year, but it wasn't working well for us, so we switched over.
Now, did you guys design a lot of these piece parts yourself?
Yes.
It's all custom.
All custom?
All of the, how many parts are there?
We have
29.
29, something like that?
20, I think that's the total number of parts,
Okay.
but there are some.
So like
repeats.
even the case for the, that's the Bosch, they printed that, but everything that's on there that it's white
It's not the
is a
frame.
nylon part that they designed for that
Nice.
scratch.
Well done.
Are we going to, should we do vision? That's
Yeah.
Yeah.
still not our image, but okay.
So we're gonna describe, let's put the robots down. Just on the ground.
I'm gonna-
Unfortunately, our beacon is broken. So there's, you wanna talk it through, or please? Go for it, go for it. I'll add it and stuff.
All right, so in order to increase the actual range we have to press the beacons, because in autonomous our color sensors don't have a very large range and we have to go really slow when we're passing over it. And we have a limit of 30 seconds to press both beacons and do whatever else we need to do. So we were running out of time a lot. So we decided to try using computer vision, because that would give us a much larger range of view and it would save us time because we wouldn't have to go really slow to make sure we didn't accidentally miss something. So we use Vuforia to analyze to track the pattern here, and OpenCV to track, well not to track, but to, what's the word?
Do color analysis?
Yeah, and analyze the configuration of the beacon so we know which side we need to press. So Vuforia is another set of computer vision methods, I guess, that track patterns. So you can give it a pattern and it will be able to recognize that pattern. It doesn't really matter if it's turned or if it's upside down. It'll still be able to track it.
That's a Java-based?
Yes,
It is.
it is Java-based.
Okay.
So we have a demo of Euphoria. So
We may need to,
because we're still plugged.
all right.
Yeah.
All right. Excuse me. So we have so the phone camera is facing outwards on this phone. So we can put this in front of the phone, and it will start to track it. Can't really get in front of it.
So what it's doing is maintaining distance to the target, and it's using PID to control the motors. And Euphoria actually gives you things like the absolute location, like how many degrees off it is, what the distance is in millimeters, because it's sort of a pre-calibrated target. And in their full field things, they can basically, there are 4 different targets that you saw. There are 4 different beacons, but each one has a custom target under it, so you can identify which beacon you're navigating to. So you can use that to get close to it, and you can track up to 4 targets simultaneously. But it also gives you your absolute position on the field if you calibrate it. You do all your transforms to say this is where these targets are properly located, and then it can tell you, you can learn from your robot exactly where you are. So for example, if they were to try and adapt this, it's not a legal robot to do can-can, right? Or is that what it's called these days? So,
Can-can soccer, which
Yeah,
would be
can-can
against
soccer.
it, yeah.
So if it were example, I mean, I think it's too heavy for one
Yeah,
thing.
yeah.
But if we were allowed to substitute the balls for the cans, they could have the beacon on the side, I believe, by the rules, right? And use
Yes,
that to
yes.
identify their location
Yes.
at all times, and so
Mhm.
they should be able to score using the existing shooter system. So they might try and do that as a demo, but it depends on how
That'd
much time we
be
have.
cool.
And we'd use OpenCV to track the cans. Like in the future, we're planning to track the particles using OpenCV. That isn't working yet, but
Well, we've done it in the past, so.
yeah.
Okay.
But we
should
can
be-
track the
Should be
cans.
easy to do.
So one of the questions that comes to mind real quick is, so you found the beacon with your camera.
Mhm.
How come you didn't use something like like an arm that would shoot out and just push the button? Because you know how far you are. You know what I'm saying. As opposed to now, you have to rotate 90 degrees so that your erasers are in front.
We also have 2 beacon pressers on the front.
Oh, okay. I didn't see those dudes.
They are, I forgot what they're called. What were they called?
What do you mean, what are they called?
The pieces of tape.
That's just that's just foam tape,
tape,
basically. It's weather stripping that also conforms pretty nicely. The plan is to replace those with NinjaFlex, but there we're sort of running out of space. We got to fit inside this 18-inch cube, right? And we're like right at the limit. front to
17
back.
3/4.
We're like we're like splitting a millimeter between. So they've got these very accurate sizing cubes, and we were like having how many? It took us what, 5 visits to the
Yeah.
thing to get it right.
And we actually,
Yeah.
the issue was the rubber bands in the front because they were sticking out, and we never had an issue with that because usually when they put the box down, it was like covered on all sides, so they were just like pushed on the rubber bands. But the one at Super Regionals, the front wasn't there, and the lady had a wood block that she would just go like this towards, and if it would stop, so it
So
stopped
it
there.
touch anything.
Yeah.
So it's not allowed to compress. The box can't compress any part of the robot.
Yeah, so we had to take out a section of each of the front rubber band parts. But the outside and the inside have different like rotation frequencies. So we totally calculated it would become all no rubber bands at 14 turns. But yeah, that's what we had to do to get through that inspection.
So that's the no rubber band section right there, right in front right
You
now.
see it, and there's a gap every once in a while. It doesn't really make
Doesn't make any
impact
difference,
on the-
yeah,
on
okay.
the capabilities
Cool.
of the robot.
Read that one behind you.
To explain the Vuforia and OpenCV combination a little bit further. So the Vuforia is what tracks those targets, and we can get pretty certain about exactly where we are in front of it, and it's pretty immune to different lighting effects. So it's a pretty solid approach. Then what happens is that we know where the beacon is supposed to be in relation to that Vuforia target. You know, it's up a certain distance. And what we do is we take the full frame that we're getting from the camera, we get the location of the target, and then we project using OpenGL transforms where the corners of that beacon are, so that we can project it and get the actual crop. We can crop to the beacon itself, so that we always know that the beacon is within this sub bitmap. And then and this is not something we thought of. There was another team that posted this idea, but we're using it. And so once we have that cropped image of just the beacon, then we can start doing analysis on which side of it is blue and which side of it is red. And then we obviously have to match it to our alliance color, because if we press the wrong one, we give those points to the opposing alliance. So
They don't get a particle, though.
it's a risky operation, huh?
They don't get a particle though.
They don't get a particle, but they get 30 points.
Yeah, they do.
And that could be, we did that once, and it gave the match to the opposing alliance.
Although that wasn't due to the problem with the analysis, that was just due to a problem with our robot, so with our odometry.
That was a classic mode.
That was our odometry,
Yeah.
and we were misaligned.
One of the things that we learned last year is that the red is a really poor signal on the particular phones that we're using. The blue comes in really, really strong. It's always clear exactly where the boundaries of the blue are. But depending on lighting conditions, the red, and this is you can see it's a white shell, so it's illuminated from behind. But if there's a lot of daylight or anything like that, it's going to tend to skew it to the red side. And so the actual algorithm that they're using is they're relying on knowing that they have a good frame on this, and they're only analyzing the blue and seeing where the blue is and inferring where the red should be from that. But that tells them what side of the so they need to choose one of these two buttons. So it tells them which one they need to choose, but then we go back to Vuforia tracking and we do an offset from the center and say we want to go here, and then just go up and ram against it. We shot?
We've shot. We have not talked about the IMU yet.
You've demoed the IMUs before
Yes, we
here, but just quickly.
Well, you disabled it. Well, there goes the beacon.
Last straw. Boy, those buttons are just really un-robot friendly.
They are. They really are. Yeah. So again, this is the Bosch B&O 055.
That's not 6. That's the wrong one.
We're running some other autonomous right now?
Yes, we are. Okay.
Some other demo?
That was bad. Can you center it back?
Anyhow, he's, you want me to do that? He's just going to show you station keeping based on the IMU. We're doing, in our classic autonomous mode, they're doing a lot with IMU corrections. We don't have a proper video of it, but everybody at the super regionals was looking at our robot very closely, because you'd see it making these fractional degree adjustments to get it exactly right. And you can do that with that particular IMU. It's just accurate enough. And it lasts for the full match. There's almost no drift in it.
Yeah.
It's great.
Are you, Kareem, on the O055, what mode are you running it in?
We have the magnetometers turned off.
You have the magnetometers, but you're still running it in IMU mode, or so you're not running in gyro mode or whatever they call it.
Yeah.
Okay.
We're not doing our own integration. We're relying on the solution that it provides,
All right, go on.
but ignoring magnetometers, because every environment you go to is different.
Just too different.
The time that you spend doing the calibration is just not worth it. And it's solid without it, huh?
You reset your
There's also wiring
orientation
into the
in
field.
the middle of a match, like if you drive up to a wall with the target, you then...
Yeah, they added
reset
that
your
into their
orientation.
pose class as a way. So they Their software does, it tracks the location on the field at all times from the starting position. So they set an initial position, and then it'll use trig based on how far you've traveled and when you've turned to calculate, to update your new position. That is a little bit, with the Mecanum wheels, there's a little bit more uncertainty and drift earlier than some of their previous drive systems. I was just getting to your question and I've forgotten what it was specifically.
You reset your orientation.
Yeah, right. So
they
they have this long-term orientation that maintains from the beginning, but they also have a short-term where they can reset it and say, I want to turn relative from a current location by a certain amount. And so the IMU library that we incorporated doesn't have that in it. That's something that they pulled into their robot.
So one of the demos we do with our IMU is to show that we can maintain a heading with just like autonomously, because right now it's set to the position that started in, which is this orientation. So if I rotate this block, it'll maintain that heading, whichever way I turn it.
pick it up and rotate it 90 degrees.
Yeah.
Rotate back to the end.
It will, because, well, it'll try to, because I'm going to be levitating it, but...
Your hand is on the switch, be careful.
So that's
So
what
it
it's
means
trying.
if you pick it up and
Put it down 90 degrees
Well,
off.
then 90 degrees.
Oh, yeah.
There you go. Right, next speaker's on there.
It's not odometry
Yeah.
for that particular one.
Yeah, and you're maintaining that for, how long is the match?
It's 2.5 minutes.
2.5 minutes? And,
So there's an autonomous period of 30 seconds, but there's also a break after that where they're tallying up the points in autonomous. So it typically takes at least 2-3 minutes of a break, and then it continues for a 2-minute driver control period.
okay, during that,
We're not really using the IMU in the driver control period right
yeah,
now.
yeah. So you don't really know, you guys have you guys ever tried to figure out how long before drift becomes a major issue?
We have, I think we did that a while ago, but that was
Last year.
last year. I don't remember.
So does-
It just didn't show, I mean,
It wasn't
our window,
enough.
we weren't doing like really long-term tests. We saw in 5 minutes that it didn't even change by a degree.
I
It
will
also
say
forced
this,
you to turn off your robot between the autonomous and tele-op phases, so you're only running it for one segment of 30 seconds and then a second segment of 2 minutes.
yeah.
David?
Well, we've had it on 10 or 15 minutes now, right?
Yes.
And if
Right.
it was drifting, wouldn't it try to move to stay with
Yeah,
the
does
drift?
Yes.
Does
It
it
would-
have
it would
any,
be
So it's not moving.
Yeah,
No, it's very stable.
yeah, I know that, for just,
That was a great find. We really appreciate you
Right.
pointing that out to us. A
2
lot of
years,
other teams are
yeah,
jumping
yeah,
on
2
board.
years ago, I went to the SparkFun event, and that was the main sensor that everybody was using.
Yeah.
I mean, they were going 100 yards, 100 yards, 100 yards, 100
Yeah.
yards.
And it's very stable under vibration. you
Yeah.
know.
Yeah,
Which our robot does a lot.
Yeah.
Maybe that's, I was just curious if the IMU received any notice that you weren't driving, but maybe it's just smart enough. I'm just wondering if it has some help internally for drift when it knows it's not moving. In other words, if it notices the accelerometer is not bouncing around much and the gyro is saying about nil, then I'm wondering if it can use that to achieve a better zeroing and a better nilling of drift.
I'm almost
rotation.
certain it is doing that. We don't have the details, but I saw some articles about people musing about how it works. But that's all proprietary to Bosch, and they haven't really shared. the
Because that would
internal
make sense. It could sit there for 3 hours.
Yeah.
If it's good enough to know that it's not moving, then if it thinks it's moving just a little bit, it'll say, nah, it'll null it. So, okay, interesting.
But unconfirmed.
yeah.
Anything else you wanted to show, talk about? Any other questions?
So how many man hours or years, how old is this particular
This
implementation?
spot is a year old. It's
Less than
It's
that.
like,
It was
I'd say 8
midsummer
months.
when we started.
Oh, yeah.
I'd say 8 months.
It was late summer when
Yeah.
we started building
You-
this.
Before
frame.
before this season, we had a pretty standard drive chassis, which was with the Omni wheels. And basically what we did was we took that drive chassis, and because it was so like functional for many competitions, we used that. last year, which is what that was for, last year there was a competition. The competition had the majority of points was you climbing like a small little mountain, and we didn't. The Omnivores didn't give us a lot of traction for that, so we switched to like a tank tread system.
We were
And-
hoping to use the Mecanum wheels last year,
Yeah.
but then it was revealed that we had to climb stuff, which Mecanums are not good for.
Yeah.
Because it didn't matter if you went up or sideways as long as you went up,
Yeah.
but it would slip.
So like those tape measures last year we used to climb that mountain because of the high amount of surface tension for each inch of the tape measure. And that used tank tread system. So that's last year was the year we started doing completely new bots every year.
Before that, we'd used one robot for 3 years.
Did we ever demo this thing?
No, we did not.
That's awesome.
Do we have a battery? Here's the battery.
Let's see,
Software or?
is this safe? Is this safe to do?
We do
Is it
not.
gonna go the right direction?
We need both. We need both of these to run because.
No, one will drive the other.
Okay.
But I'm not sure if it's cued in the right direction to go out. Oh, it is.
Oh,
there
it's
we
gotta
go.
Okay. All right, so this is, Max figured this one out. So one of the things that you had to do last year was pull, we had a 35, 40 pound
Basically,
robot,
a really
something
heavy
like that.
robot compared to the rest
Yeah,
of the competition.
and then there was this aluminum fake mountain. It was basically a steep ramp that came up like that, and then there were bars.
There was
open,
also a
and
second.
open space.
There was a second portion that was even steeper than that as well.
Right, yeah, so there were two different levels of steepness, and then it went vertical. And if you could hang from the very top at the end of the match, you got 80 points. So it was that was a big scoring opportunity. And so some teams started figuring out that they could use tape measures, and this one was the double wide. So we could control its angle. Right, there was another motor here. Whoops, I gotta go.
You might want to stop it now.
Yeah. So it could control the angle. So this part was attached to the robot, and you could, figure out exactly, because there are certain parts of that structure that if you touched it, you'd lose points. So you had to be very, very accurate in how you got it out there. And then when we retract it, it can lift, it can lift 80 pounds. Easy. So one of the videos that we used to convince other teams to, I don't know, we don't have that.
It's
but-
way up.
Huh?
It's way up in our group me, so it's not going to be easy to find.
Okay. Was at like, I think it was a
It was a
qualifier
qualifier.
competition last year.
I think so.
We hooked it up to a basketball hoop, and the robot just free climbed itself all the way up, and it's like, and we were actually doing horrible that tournament. We were 32nd out of 32 teams in the regular qualifying rounds. Everything possible went wrong, but it all came together at the end, and they were actually able to do it during the finals. So we convinced the first place team to bring us in as their first alliance pick.
By showing them
And
the video.
By showing them the video.
Even though we were
at the tournament.
dead last place.
And we went, and our alliance won.
And then we won.
How long does it take you to tear this apart and put it back? I assume you
The
can
whole
take this
thing?
down to the, or you just don't really take it
We don't take it apart. We
Well,
just,
You take subsystems apart.
Right, that's kinda what I mean.
But they haven't been down to the actual Mecanum restructuring for like 4 months probably.
Okay.
And but before that, there were a whole bunch of workarounds that they had to get going that just to make it so it would work. Like it's a chain drive system, and the chains under rapid directional changes would obviously pull on the sprockets, and so you just got this vertical aluminum structure there, cross beam, and it was basically pulling in. It just didn't have enough strength. So they designed those nylon side, what do you call them?
Side guards.
Yeah.
no bounce.
So that nylon is stabilizing that aluminum connection, and once they got that right, it hasn't budged since.
Yeah, so the beginning of the year was basically just like
Oh,
Mecanum,
it's
and then build down again, build it up, and then build the side guards, and after that, everything else just stayed pretty much constant, except for the shooter, and then we had to tear that out a couple times too.
Yeah, the side guards, what was it doing that you were correct?
Well, it was the force of it turning and inverting was pushing the robot in. So the chains that were on the sprockets, they were like this linear, and that was fine because it was just running like this. But once one side went linear, one side went inwards, the chain would just fall off, and then we couldn't drive. So the side guards helped counter that force, and then it just made it stay here.
So the air condition was the chain.
That's
Yeah.
correct. That's correct. But the reason for it was because
Yeah,
it just wasn't a good structure to keep the wheel in
It's
its
a clever solution.
place.
I thought, from previous presentations that you made, that you guys had decided to go to belt drives over chain drives.
We had looked at, we have belt drive gear, but we just never got good at it, and the chain drives have been solid
Okay.
for us. I mean, the reason, the belt drives would have failed for the same reason in that, in
Yeah,
this
yeah.
case.
I'm just
Right.
curious. I thought that you were moving away from belt
Yeah.
drives.
From chain.
I mean,
yeah.
chain drives.
Yeah, no, belt is probably a little bit more accurate, and if you get a wide enough belt, they're more than strong enough. We just never got there,
Okay.
basically. It's like, you choose the battles you want to fight, and there's so many other things that they're learning about. They've never done mechanums before. That's a whole different control scheme, and instead of just keep taking somebody else's code, Tycho decided to sort of build it from scratch, so he really understood how it all worked. And so that, those kinds of things take a little bit of time. We're getting more sophisticated with the machine vision, and that takes a lot of time. And so, yeah, we probably should have made that move.
Well, I was just curious. I thought, you presented
about it.
before,
Yeah.
and I thought you'd said that,
Yeah.
hey, well, we're getting rid of those chain drives. We're going to go to belt. So I guess the answer is not yet.
Yeah, not yet. Not yet.
So that's pretty cool.
Oh, the lift.
Yeah,
Which
the
we can't
lift.
actually show you, but
But we can physically.
Can you make the whirling noise as it comes up?
okay. So what most teams do, this is the smart thing, is to build the lift into the structure of their robot, so you don't have to do something like this, right? We have to deploy it.
Because our robot has no space.
We were totally out of space. We were trying to get as long a wheelbase as possible because we're also higher up off the floor than we were before. With those big mechanical wheels. Yeah.
That's the important part.
Yeah. Wait.
Lightfoot's on it.
Where's the box? I think you got some zip ties on that.
Probably. Yes, they're still here.
It's not just decide to take off.
We've had it happen before. Yeah, sitting there on top of somebody bumps that controller, it can, if it's in teleop mode, it's gonna.
It is not in teleop
Take
mode,
off.
so that's a good thing. Let me get
These are not properly
No, they're
aligned.
not.
Oh.
This is why we kind of didn't work with it that much.
Yeah, it's a complicated system. I think these are supposed to be up here.
For our team at least.
What we're gonna, so the idea is that it basically pops up, so it's spring loaded, and it'll pop up in this once we release a servo. We don't have the strings on here at the moment, but basically these pop down, and when it's all timed right, this is basically a fork system, and there's a big yoga ball. It's called the cap ball, you might have seen in the video. That basically fits inside here, and then the job of the lift is to take it up. And so this is just a series of linear slides that are, and there's a single motor that operates the whole thing. So it pulls on the slides, pulls on the pulleys, and it'll go up. Well, I can't do it all here, but
It'll
go up pretty high.
near 6 feet, I think.
Huh?
think
Yeah,
it goes up
it
near
goes
6
up
feet.
more, yeah. So it has to clear 4.5 feet in order to get the ball. The bottom of it has to clear 4.5 feet from the ground in order to get the ball over into that center vortex structure. So, and yeah, so that was torn apart when it was a little bit misconfigured, and it just torqued itself to pieces. But being able to, whether or not we were actually going to be able to get it reliable enough for competition, it would have been helpful in the judging to be able to show that that's part of the progression that we're going through.
So what were your guys' highest score?
It was, I think, around 200. I don't exactly remember what it was.
Okay,
You got one that was a 230.
Yeah, okay.
230. Did you ever get the cat ball? I mean, when this was working, was the cat ball get in
It
the
was
little
never
basket?
working during a competition.
Okay, and practice it worked great, right?
It worked maybe twice.
Okay.
Worked maybe twice.
We had like about 2 chances to test it. And then,
This was developed very late in the season.
yeah.
Gotcha.
And then it got
So a bit of this has to do with strategy. There's only 40 points available for capping, to actually getting it inside the top thing, and only one robot on your alliance can do the capping. But
And
there's
as soon as you
also
cap, you can't score particles anymore.
right. But there's also 40 points in play for turning the beacons to your alliance color during the end game. So if you're doing this, you're not helping with that, right? So there's a trade-off, and so this is one of the lower priority. It's a thing that's expected by the judges that the teams would work on, but it doesn't have a huge payoff, and it adds tremendously to the complexity of the robot. And so we always deprioritized it until later in the season.
It's also a huge time sink.
It is a time suck, yeah, there's no doubt about it. So,
We lost some points in autonomous because we focused on the cap ball system that didn't work.
yeah.
But you go into it thinking, oh, we'll get this in a few days.
Well, yeah, exactly, and it turns out to be a lot more work.
This is good professional experience.
Exactly. Exactly. So they're still planning on working on it for state, I think, right?
It's a lower priority though.
It's like that close, but it's still a lower priority than getting the autonomous even more solid.
Getting
And
any driver
getting our
practice.
particles. Yeah, one of the things we do not do well compared to other teams is drive practice. Nobody on our team wants to actually drive the robot.
I don't want to drive.
And, it makes a difference how good you are at driving the robot, right? And so Tycho ends up being the driver mostly because he gets the most practice because he's also the programmer, and so he's got to test it out. And it's being built at our house. And so, so he becomes the default driver. And so there are other teams where they have, regular driver practice, and they make sure that they have, hundreds of hours doing it, and we don't do that, and so that we suffer
Yep.
as a result. Anything else?
That's pretty amazing. What do you guys think? Yeah. Well,
Hey, do you guys one more?
I have a comment.
Huh?
I've been watching you guys do this for how long, 10 or 15 years? Been there?
Yeah, it's probably the official team has been together. We've just completed our 8th year.
But I mean, since
Yeah,
you
and
guys
before
started-
that, you've seen
Yeah.
my boys doing
And,
stuff.
Right, and the progress is astounding and pleasing.
Thank
See
you.
what you guys have done.
I'm really proud of them.
This is
They've
very
really grown. They're a
sophisticated
very
robot.
strong team. Yeah. I mean, they're doing. This is college level work. I mean,
Excellent.
easily.
Here you
So,
go.
they're doing great.